We'll start by reviewing the architecture of web applications to be able to compare them with online applications for smart devices. Lastly, we'll see a particular example of these applications when using the Knowledge Base Navigator. In web applications, the client requests access to certain content from a browser, such as the web panel of the countries work with for web component. The server will be in charge of querying the database, obtaining information from the countries, and will generate the corresponding HTML code, which, once generated, is sent to the web browser that interprets it and shows it to the user. So why don't we use the Smart Device browser to access the same web interface of the server? Because we wouldn't have the same look and feel or access to integration with the device hardware natively. So, we need a different alternative. We could also have, in our application, a service layer, especially a REST API made up of business components, processes, or data providers. One of the advantages of REST APIs is that they will allow us to not only retrieve information, but they'll also provide us with adequate mechanisms to update it. In addition, they use JSON as output format, and therefore the information is independent of its representation. Using this REST layer, when the web server is asked for access to a certain resource, such as a data provider that returns a JSON with the country's information, the server will search for the corresponding information on the database, and will generate an output in JSON format, which is finally returned to the client. Next, the client must process this data and display it in a particular way in the user interface. If we think of the latter case, the client could be a device such as a phone, and the interface could be a panel for smart devices. Solving data access in a natural way and leaving its display to the client side. Now we can define the architecture of online applications. As we've seen before, each smart device platform has its own language, Java for Android and Swift for Apple. When the application is compiled, a file is generated which is installed on the device. This file will contain all the logic to implement the user interface, such as images and other resources. This includes the URLs of all the REST API resources you need. This is called application metadata. When the application runs, it accesses the web server to run the REST services, which will return the current data. This data will be processed by the application and deployed to the user. One advantage is that the application will never access the database. This will always be done through the services layer, the REST API. And this layer will be independent of the device we're using. That is, if we compile the application for Android and iOS, both applications will use the same services layer. One particular case of online applications is a mechanism provided by GeneXus to run an application in an interpreted way. This mechanism is used when we want to run the application on an iOS device and we don't have a Mac to compile it. In these cases, GeneXus provides an application called KBN, Knowledge Base Navigator. This application can be downloaded from the Apple Store and installed on the device. Also, in the developer menu, a download link is provided in addition to the link to add the app to the KBN. KBN is a native iOS application which allows browsing the smart device applications created with GeneXus as if in a browser by selecting a URL, corresponding to a main object of the application. Basically, it's a light interpreter, which has the logic to read the metadata from the web server, as well as the application images. Also, it'll be able to decode all that information, invoking, if necessary, the REST services needed to obtain the answers with the data, and then display the corresponding interface in the device, which is the one viewed by the user. You can find more information about this mechanism in the GeneXus wiki.